Hi everyone, in today's video we will be covering chapter 6.5, which is on manipulation of algebraic formula. The objective of today's lesson is that you will learn how to change the subject of a formula. So what exactly is a formula and what do we consider as a subject? So we will begin by taking a look at this example, which you might find familiar because we have done something similar back when we were in Sec 1. So in this question itself, we are given a formula. I am not sure whether you find this formula familiar. It is actually your parameter of a rectangle. It doesn't matter whether the formula is something familiar to you or not. Okay, we just take it as a formula for us to manipulate for later on. So we are told that P is actually equals to 2L plus 2B. We want to find the value of L such that P is equals to 132 and B is equals to 30. So when we have such a question back when we were in Sec 1, what we will do is that we will replace the P to be 132 and the B to actually be 30. So we will start off by doing that, as shown over here. Then, because our objective is to find out what is L, perhaps what you will do first is to compute out what is the value of 2 times 30, which is actually 60. And since our objective is actually L, we will first begin by moving the 60 over to the left, okay, such that we can leave L behind, so that our L is the subject, it is the main objective of our manipulation. So we will get 132 minus 60 is equals to 2L. Some of you might be writing it in this manner, some of you might not be writing it in this manner, okay, but fundamentally, you need to rely upon correct algebraic principles and correct algebraic concepts. So we see now that 132 minus 60 is equals to 2L. You could proceed to compute it, okay, but I'm going to leave this as it is for now, okay, so that I can draw the parallel later on to show you what this chapter is about. So I'm going to leave this alone, 132 minus 60 as it is. Our next step to finding out what is the value of L is that I need to divide by 2 over to the left so that I can only have 1L. Because the question is asking me for the value of 1L. So that will mean that 132 minus 60 divided by 2 for the whole thing will give us the value of L, for which I can compute out in this case, and that will give us L to be equals to 36. Okay, so if we look at this step, this is the process, okay, that we have gone through in order to achieve this answer here. Now I'm going to change this question a little, and that is going to be the objective of our lesson today. So now what we're going to be looking at is a question that asks, make L the subject of the formula for P equals to 2L plus 2B. So the formula in both cases are actually the same. Alright, what it means by making L the subject of the formula is that we want just a single L. Okay, the unique thing about this question is that there are no numbers given to you. But does it really matter? Because P and B, they are none other than just representations of a certain number. The way we handle this question that we're seeing in this chapter is no different from what we have been doing earlier on back in Sec 1. So having P equals to 2L plus 2B, okay, we are just not going to replace P to be 132 here and B to be equals to 30. Right, so there's nothing for us to compute. Remember, our objective is L. So what we saw over here is that I moved the 60 over to the left. And that should be what we do. And the 60 in this parallel is the 2B. So we move it over to the left such that we can get P minus 2B equals to 2L. Again, a reminder, we want to find the value of 1L, so we need to get rid of this 2, and this refers to 2 times L. So to bring the 2 over to the left hand side, I need to divide it over. So that means that I'm having P minus 2B divided by 2 equals to L. In other words, L is actually equals to P minus 2B over 2. And this is what it means by making L the subject of the formula, meaning to say that we want to start off with L, unlike the earlier formula where we start off with P. I hope that drawing these two things together will help you to see that we are actually doing nothing new, alright, in this particular section. Let us take a look at this example in practice now 9 question 1. In this question, the first part asks us to make A the subject of the formula for V equals to U plus AT. Again, it doesn't matter whether we recognize the formula or not, so long as we take this as the formula and we want A to be the subject, that shall be the focus of our question. So I'll first begin by writing down the formula that we are given. V equals to U plus AT. For the convenience of teaching, okay, I'm going to highlight A itself, which is the objective, okay, of our question. We want A to be the subject. So I want my A to be left alone, basically. Alright, so in order to do that, I will usually tackle the things that are furthest away from A. And I recognize that the furthest thing away from A is actually this U. This U is actually added to AT. So to so-called remove it, I'm actually shifting it over to the left-hand side of the equation, or to be even more particular, I'm referring to balancing the equation on both sides. So when I shift U to the left-hand side, I will need to write it as V minus U, because minus is the opposite of plus. And that is the thing that we need to do when we shift things over. So in the next step, I will say V minus U equals to AT. A reminder again that A is the objective. Okay, so the thing that we need to get rid of now is T. So how do we get rid of it? We balance the equation by dividing by T on both sides, or in other words, I bring the T over to the left-hand side. And since it is A times T for the expression AT, to bring it over to the other side, I need to divide. So I write as V minus U over T equals to A. Since I want A to be the subject, we will write it as A equals to V minus U over T. And that will be the answer for part I. Next, we look at part 2. Part 2 says hence. So I'd like us to take note of this word here, hence, which means that I must make use of my answer in part I. The question wants us to find the value of A when T is equals to 4, U is equals to 10, and V is equals to 50. So I now have numbers over here. So since I need to make use of our answer in part I, which is the formula here, A equals to V minus U over T, I do not and should not in fact start from the beginning again. I just have to let T equals to 4, U equals to 10, V equals to 50. And that is what I've done over here. I replace the letters or the variables with the respective numbers accordingly. Subsequently, I can then calculate this into my calculator and I will get a value of 10. So this is how we solve a typical question on changing the subject of a single formula. Next, we take a look at practice now 11 question 1. We have 3y equals to square root b squared minus 4ax. So this formula might look a little bit intimidating, but don't worry. So long as we are able to apply and be consistent in the concepts that we're trying to apply, okay, it wouldn't be a problem. Alright, so let's start off in part I. We want to express x in terms of a, b, and y. So what does this actually mean? This means that I want x to be the subject. Okay, so given the formula here, I want x to be the subject. Okay, so imagine that x is actually now found under this roof, which we call square root. Okay, earlier on I said that we tackle the things furthest away from x first. And the thing that we need to first remove is the roof, the shelter. So imagine x is inside the house. In order to enter the house, we need to open the door. Okay, so we need to, in this case, okay, the door is actually this square root sign. So what is actually opposite of square root? I hope you're aware that it is square. So we need to square, okay, the left hand side. And to square the left hand side, I'm referring to squaring the entire 3y. Okay, all of 3y. So everything on the left hand side of the equal sign will have to undergo the square. Hence, I put brackets around 3y. Okay, and then I square it to be equals to b squared minus 4ax. So we know that 3y bracket square is the repeated multiplication of 3y times 3y. In other words, it is 9y square. So I now have 9y square equals to b square minus 4ax. So our objective still remains to be x as the subject. So the next thing that's furthest away from x now is actually this b square. Okay, but let's observe this entire expression. We see that b square minus 4ax. I usually don't quite like minus signs if you know me well. Right? So what I'll do is that, okay, to try to kind of manipulate or overcome this negative problem, I will bring this minus 4ax over to the left so that it becomes positive, easier for us to handle. And then my 9y square, since I don't need it on the left, together with my x, I will place it to the right. So I am going to get 4ax equals to b square minus 9y square. I hope you see that I have just shifted one term to the other side and then 9y square to the other side as well. So this helps me a little, okay, relieves me from having to deal with something negative. Right now I have x over here, okay, and the 4ax is actually entirely positive. Alright, so I want x to be the subject. The only thing that is beside my x now is 4a. You could recognize it individually as 4 and also a, but for convenience, it is much easier for us to recognize 4a as a group of things that is multiplying with x. So because this multiplication over here, to bring it across to the right hand side, I am going to divide. So x is actually equals to b square minus 9y square divided by 4a. Alright, and that is how we express x in terms of b, y, and a. Alright, so I hope you understand this question now. It is just another way of phrasing to ask for x to be the subject of a formula. Now we take a look at part 2. In part 2, we have hence again, which means that we must use our answer in part I. You will definitely be penalized if you make use of something else to solve for your answer in part 2. So using our answer in part I, which is this formula over here, I will replace a to be negative 5, b to be 4, and y to be 2. So in replacing, I need to put brackets around them most of the time. So our x is actually equals to 4 square minus 9, 2 square over 4 negative 5. Notice that there are brackets around my 4 because I'm only replacing the b, not the square. So my square should be outside of the brackets. Likewise, my y is actually replaced by 2, so my square is outside of the brackets. And then my a is actually negative 5, which I place in brackets as well. Since this is supposed to mean 4 times a, if without the brackets, it will become 4 minus 5, which isn't going to make sense and not consistent with the formula that we have. So with this entire formula over here, okay, this entire value being substituted already, so we can press it into a calculator and we will get x to be equals to 1. Alright, so that is how we solve part 2. Now in part 3, it looks a little bit complicated, but let me break it down for you. It says that for x to be defined, meaning to say that for x over here, for the value to actually be a valid value, okay, a cannot actually be equals to t. We want to find the value of t. So what this means is that if a were to be a certain number, my x will not be a valid number itself. Right? So the question is actually asking, what is this number, okay, that they have put as t? What is this number such that it will cause my x to not be a value that I can calculate for, to not be a value that I can find out from my calculator. I do not want to see a math error on my calculator. Okay, so looking at this formula itself, alright, what is it that about a that will cause x to not be able to become a valid value? So we see that a is actually in the denominator, okay, and it is actually with the 4 as well, so it's 4a, right? But it really doesn't matter about this 4, because if you think about it, if my a were to be 0, what's going to become of this? Regardless of the value of b or y, okay, whether is it 0, 1, -3, 1,000,000, 1,000 for my values of b and y, so long as I divide by 4a such that a is 0, my denominator is going to be 0, and I will be dividing by 0. Can we divide by 0? We can't. Okay, so because we cannot divide by 0, it causes my x to not be defined. I cannot find a value for x. So this value of t over here is none other than 0. Okay, I hope that I have sufficiently explained to us why is it that our answer for part 3 is this way. Okay, do let the idea sink to you first. Okay, if you don't understand, we'll see each other for class in the next time. Alright, moving on to take a look at practice now 11, question 2. In part I, we want to rearrange p equals to a plus bx squared over 3k to make x a subject. Again, a formula that looks a little bit intimidating, okay, but don't worry. Alright, given this formula, let's emphasize on what we want to find first. So we want x to be the subject. Okay, so what are the things furthest away from x? Right, I would recognize that as a. So it is a positive a. I need to bring it over to the left. I can say p minus a equals to bx squared over 3k. So again, x is the objective. We ask ourselves again, which is furthest away from x? And that is actually our 3k at the denominator. Okay, b and square are very close. The one that is separated out from x is actually my divide by 3k. So I need to bring it over to the left, and that will result in 3k times p minus a equals to bx squared. Again, x is the objective. Okay, this square over here, let me grab my laser pointer. This square over here is for the x. I want us to be clear about that. Okay, so this is actually b times x squared. In other words, b times x times x. Okay, but let's not break it down into b times x because that's not helpful. We want x to be objective. The thing that's furthest away from x now is actually b. So we need to divide by b over to the left, and we will be able to get this. And the last thing that we are hindered by is actually the square. Our objective is this x. So with square being the thing that's hindering, the opposite of square should be square root. However, if you remember, okay, in certain occasions, whenever we take square root, okay, when we're solving for something, we need to take positive and negative square root. Alright, so this formula over here can be rewritten to be as such. Then I'll continue my working at the space here. So because we're going to take square root, I need to have both positive and negative. Hence, x is equals to positive negative square root of 3k times p minus a over b. I want us to remember that this square root sign is supposed to cover the entire fraction, so do write it properly. Okay, so that is how we solve part I. Part 2, I hope it isn't a challenge. It is the same as what we have been doing earlier on. We want to find the value of x, and by using our formula in part I, such that a is -1, b is 2, k equals to 1, p equals to 5. So we replace the individual variables here by the corresponding values here. So my answer will be x equals to plus minus square root 3 times 1, where k is 1, times p, which is 5, minus away, a is -1, so it's minus -1, divided by b, which is 2. Don't forget the square root, don't forget the plus minus sign. So if you can compute the value inside the square root sign itself, we will get a value of 9. So this is plus positive and negative square root of 9. Square root of 9 is none other than 3. So our answer will be 3 or else -3. I hope that with these few examples, you're able to get an idea of how we make something a subject. These are the basic examples. Okay, I want you to be familiar with them. In our next lesson together, I will show us slightly more challenging questions, okay, when it comes to making something the subject of the formula. Alright, I'll see you in the next lesson. Thank you. Bye bye.